tomorrow. All right. So today we're going to, oh, this is your homework first. All right. So let's quickly just go through this homework. I would really like you to get used to doing your transformations one by one without your calculator. Keep track of what's happening to each transformation. That had just a vertical shift down, and make sure you use the proper words. Reflection, vertical shift, horizontal shift, pretty much a reflection, pretty much those things. All right, so scan over these. I'm just going to go through them quickly because a lot of you work together, so I'm sure those things are good. And then the only thing that's going to affect this asymptote is your vertical shift. So start with your asymptote y equals 0 and a vertical shift at 3. The reflection doesn't bother that. Good. Your transformations again, start as if you were going to solve this. Plug in a value for x. Yes. Yep, it's right in Wednesdays. It was just, we didn't do anything new yesterday for you guys that weren't here. We just did the same thing that we've been doing for 2 days. I figured just let's pull this together since I didn't know who was going to be out. Yeah.
For the y-intercept, wouldn't it be 4 because negative 2 to the 0?
Right. Negative 2 to the 0. This is the 1. And that's where your negative stays. Put it in your calc. If it was like this, then it would be 1. Mm-hmm. Good point though, because that is always like a point. Same thing if you do this. Negative 2 squared. This is really negative 4. If you did this, this is positive 4. Mm-hmm. Okay. And don't forget, calculators, go in and check it. Go in and plug it in. It's a good way to check it to get used to using this calculator. I'd like you to do the transformations by hand, but check them on your calculator. You can put your asymptote right in your calculator. Of course, the y equals 0 doesn't show up because it's your x-axis, but if it's y equals 3 or y equals negative 2, put the asymptote in there, and you'll see it. Okay, so we first do a horizontal shift, left, and then we do a vertical shift. And the vertical shift changed your asymptote. If you want to do your x-intercept, do it from your calculator right now. Just do it off your calculator. 4. You have a reflection, you have a shift, you have a vertical shift. Y-intercepts you should be able to do algebraically. Plug the 0 in for x. With the x-intercept, if you want, you can find it on your calc. If you want. This one had none, because the asymptote raised above the x-axis. And the vertical shift is the only thing that affects your asymptote. Okay. This one, if it helps, and I said yesterday, factor out the negative 1, shift it. This doesn't matter what order you put these 2 in, did it the other way. Sometimes the reflection is affected by a shift, mostly vertical. That one has a lot going on. And again, the only thing that changed your asymptote was your vertical shift. Were you guys okay with these? Plugging these in? Just getting used to using that formula. Okay. So we start with your initial. We do some kind of change here. What's happening, what rate is going on here, increase, decrease, and we raise it to a time. Question, Chris? You want me to go back to something? Or?
Yeah, I thought, no, it's just because for the y-intercept, it's negative 4 squared.
But don't forget to negative 4 squared, 16. So, yeah, so something's off on mine. But it's got to be negative 12. Oh, there's a oh, I didn't write the negative out here. Sorry. There's a negative. Where's your negative? I forgot to write the negative there.
There.
Oh, it's there. There it is. I told you I don't like negative numbers. They always get mixed up with my equal signs. Thank you. I knew it was there somewhere. And sometimes I do forget to write them. So we okay with these? Just plugging them in. Compounding 12 is a monthly. Make sure you also put it in your exponent. Compounding 2, that's a semi-annual. Round all your answers to 2 decimals. That's your money. The last one, 10, is a PERT. Continuously. We good with this? That was it, right? Oh, more. Okay, and the last one, all you have to do is plug these values in. When it's set over a long time, just make your value of time long. So I made it 100 years, and you could see you jump real fast from here to here, but then you start to slow down. You only lost $100 because this guy, when this exponent becomes negative, it makes that a fraction. Not a negative number, and now it's real close to 0. Good? Just something to plug in. And some of these might be similar to what you did last year. Remember, when we start these applications, they're going to follow this format. If you notice, everything stays with this format. A is the initial value. B is going to be some kind of a rate. And when we did your money things, and you're gaining money, you're 1 plus your rate. If we're decreasing something, you're 1 minus your rate. If we're doubling it, it's going to be a 2 in here. So let's talk about rate for a minute. If you have an increase by a certain percentage, it's going to be 1 plus whatever that rate percentage is. If you have a decrease, write these down because this is going to be helpful. It's going to be 1 minus this rate. If you have a double, then B is going to be equal to 2. We're doubling. If you have a triple, what do you think it is? 3. If you have a half light,
0.5.
okay, so 1/2. Good. So these are things that we're going to be looking at. These are what your rates are going to look like. Time is a little bit different. This is your time. Now, you have to watch what your problem says. Sometimes they start with time in minutes, then they switch it on you to seconds. You're going to have to convert. Sometimes it has a cycle. If time has a cycle, then we divide it by, it's either going to be the time, in whatever denomination, minutes, seconds, years, days. If it gives you a cycle, say it says every 4 days, then you're going to divide the time by 4. The cycle means every 4, not every day, every 4th day. And I'll show you in your table how to find that too. So these are things we're looking at. No matter what exponential function we do, they have this kind of format. So this one says the number of bacteria triples every 4 days. So this is our rate. This is our cycle. 1,000 units are present initially. This is our A. How many are present in 4 days? How many are present in 8 days, 12 days, 9 days, 1 day? Now, everything is working in days, and all of these are given in days. If I said a week, you'd have to convert that to a day, to 7 days, right? If it said a week. Another good way to start this is logically. If I start with 1,000, at day 0, I have 1,000. I have to start with something. Then I'm tripling every 4 days. So at the end of 4 days, didn't this go by 3? So I should see that. If I think that, I should see that in my table when I do this. And every 4 days at 8, shouldn't I multiply that by 3? Because it tripled. And at 12 days, shouldn't I multiply that by 3 if it tripled? So make sense out of your problems, because once you put them in your calculator, you're going to get large numbers. It's going to look strange, but make sense out of it. So I know when I go to my table, if it doesn't give me these 3 things, something went wrong. Maybe I forgot to divide by my cycle. Maybe I put the wrong rate in. Maybe I did something wrong. So we're going to start your equation like this. You have 1,000 to start with. You are tripling. And your time says days. That's our x value. But it says every 4 days. So it's x over 4. So here's your equation. Now if you want, you don't have to put it in your y equals. You can put in the number of days here in 4 days, in 8 days. This is x. These are all your x values. Or you can graph this. So when we graph this, you're just going to have to play with your graph a little bit. When we graph this, we're going to say 1,000. We're tripling. And we're going to raise this to the x divided by 4. If you have, oh, mine's not even going. If you have the 83 calculator, when you raise to a caret, you're going to have to put that in parentheses. If you have the 84s and they pop you up there, you can just put x divided by 4. Now, let's work at your window for a second. Could I ever have negative time? So x min is what? 0. Could I ever, in this case, since I'm always increasing and I started with 1,000, could I ever have negative bacteria? No. So my y min is 0. So I'm in my first quadrant. It's a real life application. Now my x max, I look at what I'm asked for. I'm asked for 12 days maximum. So maybe I'll throw in 20 days. I want to see a graph. What am I going to do for my y max? 27, yeah, that put me at 12 days. But I expanded it to 20. So, I don't know, make it 100,000? Hey, I'm tripling. I'm going to multiply that by 3 the next time around. Yeah, thank you. Whoops. It's always a challenge, this calculator. So I want to see growth. Do I see growth? Yeah. And when I look at my table, I can tell at the 0, I'm 1,000. At the 4, I expect it to be 3,000. Isn't this doing what I expected? Every 4 days, I was going to multiply it by 3. At the 8, I should see 9,000. Yep, I'm there. Now, say I wanted 5.5 days. 5.5 days. What happened at the end of 5.5 days? I could absolutely plug in that x value for 5.5, right? I could even change my table to 0.5s. Could I do that? And I can also come to my y and say, well, if I want this x to be 5.5, oh no, I guess I can't do that. All right, let me reverse my thing because I want to show you how you intersect. Say I want to know, not this, because that's too easy. Let's do, how about how many days to reach 40,000? And I can't exactly see that on my table. Can I see 40,000 in my table? I look. I'm here between 35,000 and 46,000. Do I see 40,000? No. Now, algebraically, we would set that equation equal to 40,000. But my variable is in my exponent. I would need a logs. Right now, we didn't start logs. So algebraically, we can't do it. But graphically, we can. We can come to your y, and we can set y2 to 40,000. And we can see where they intersect. Right now, algebraically, you can't do that part. Well, you can. can if you remember your logs, but I'm not going to do the logs yet. I just want you to get used to putting it in your calculator. So intersect, second calc, number 5, just keep hitting it 3 times, and it gives you your point of intersection. And this you will have to round 3 decimals for your x. So if I need to know the y value, if I've given the y value and I need to know the x value, I have to do it using this right here. I can't do that part algebraically. If I'm given an x value, that I can plug in, because I just need to get my y out. Does that make sense? Okay, so tell me, what is my x? How many days to reach 100,000? 100,000 units of bacteria? That's disgusting. How many days to reach 100,000 units of bacteria? A lot of bacteria. Kind of like when you look at the bread, and the bread's got a little green spot on it, and you put it away. You let someone else find it, and a couple days later, you look at it again, and your bread's all full of greens.
You don't just throw away the moldy bread?
Well, my children did not. They just put it aside. It says invalid. So something's off in your window. Oh, you're trash. It's not letting me. Yeah. Your plot was on. So what did we get? How many days? Do second calc, 5, intersect, bang, bang, bang.
I did not get it. It gave me first curve.
Yeah, hit it again. You have to hit it 3 times. First curve, second curve, yes. You guys never did an intersect?
No. Wait, what do you hit?
3 times, enter.
Oh.
Enter. So 16.767? Did we come up with that?
Yeah.
So we're going to change this to 100,000. Do I have enough zeros yet? 100,000. I'm just going to change my window for a second. I'm going to make this be 10. So here I changed my days to 10 because I want to show you what's going to happen if you don't have your window big enough. So here's my graph, and here's my line up there. So I certainly don't see an intersect, right? So what should I do? Which one? My x and my y? Okay, my y is up there at 100,000. So I can see the 100,000, right? But what can I see? Is my x. So I need to make my x bigger. Rule of thumb, come down and double it, triple it. You're only needing to see a graph. You're not needing to find it exactly. So now I see, can I find it? Will it intersect here? It will intersect. Intersect, second calc. Hit number 5 for intersect. You got to hit this 3 times. First curve, you see it was over there. Second curve, it's up here. And it says, okay, now you want me to bring it to the same point? They use the word guess, which is weird, but they say guess. And there it comes. If that's too high up there, just expand your y. You need a little bit more, expand your y. Remember, your window, just like we did the window before, does not have to be exact. It has to just give you a window to see this. Okay? You good with these? All right. All right, I have a population that decreases. My town is slowly losing people. Every year, 2.5% of what's left of those people. So it's not a steady rate. If I have 100,000 this year and I use 2.5, then whatever it is next year, I start at that number and lose 2.5 again. So when will it be 95,000? So I start like this. Again, this is my decrease. This is my increase. This is my rate. B is my rate. If I'm decreasing, I'm subtracting. What it is you're retaining what's left over. It's kind of like this. You go to the store and you see an item for $100. It's 20% off. How much do you have to pay for it? $80. So in your mind, you said, I have 20% off, I times 20, I save $20, I take away 20, I pay 80. Right? Oh, I hope I'm your sales register person, because I'm going to pocket your difference. So now, if you do it like this, 1 minus 20%, you're actually retaining 80% of your cost. So instead of doing this, you multiply 100 times 0.80. So now you only pay $80. So that's what this 1 minus the rate does. It says, am I retaining? If I saved 20% or I lost 20%, I'm actually saving 80% of it. Any percent, when you do 10%, just move your decimal place 1. That's 10%. If you want 20, multiply that answer by 2. If something's on sale for 30%, multiply it by 7. That's 70% of your item. That's how easy it is. Well, when I taught 8th grade, when I gave them percents, I said you have an article that's like $200, you save 20%. So you bring it up there and you only have to pay $180. I said, what a bargain. And they're like, yeah, that's good. I saved $20. I said, good. I hope I'm your salesperson because I saved $20 on your deal. They're like, what? So they have no idea how to do decimals. So remember, just move your decimal one place every 10%. If it's going to be 5%, move it one place and divide this in half. So you're going to save 5 instead of 10. So that's how a decrease works. So we're going to start like this. I start with 100,000. I am decreasing by 2.5%. How do I change this to a decimal? Good. Yes, it has a decimal in it, but it's a percent, so I need to move it 2 positions. And time, that's my x. So again, I have to find when. Right now, to do this algebraically, you need a log. But we're going to do this with your graph right now. We're going to set this guy equal to 95,000. And we're going to put this in and find where they cross. Let's start with your window. The decreasing ones are always, I find they're a little easier to start with. So go to your Y. Let's clear these out. So you start with 100,000. And your 1 minus, use the 1 minus this way. You don't have to subtract and make any mistakes. It doesn't like my 0. Thank you. Oops, doesn't like my caret either. Some days this calculator works great, and other days not so great. Okay, now, before I do this, I'm going to set my window. Again, can I have negative time, negative people? So my mins are both 0. My max, I have no idea what it's going to be. 20, sounds all right. My Y max, how would I know what to set my Y max at? Keep thinking. Greater than 95,000, because what did it start at? 100,000. So aren't I decreasing? So my max, 100,000. Does that work for you? It's the max I'll ever be, and I'm going to be decreasing. So I graph. I can always change this. If I don't like it, I can change it. As long as I see a cross, I'm good. And it shouldn't take me that long, right? Because 95,000 is so close to 100,000, right? So I should be pretty soon that this is going to reach 95,000. So intersect. Again, it's going to start, give you one curve. The second one goes to this other one, and then the third is where they meet. So in a very short amount of time, 2.026 years, I reached 95,000. If this doesn't have enough slope for you, you can always change your x. Maybe you want to see the slope be a little bit more. Just remember, all your goal is to see it cross.
Where do you hit for first?
Enter.
Go
Just keep.
where on?
Second tree.
Oh, second trace. It's the calc. It's this word calc up here. It's blue trace because you want the word calc. And number 5 for intersect. Then you just hit enter, enter, enter until it gives you the intersect. What it does is it puts that little blinker thing on one curve, then it jumps to the blinker on the other curve, and then when you say guess, it brings them to the same place. Okay? So we can see it was 2 point, what did I say, 026? Is this days, years, months, years? Give it a label. Good? The decrease is nice because that's the highest you're going to be. The only thing you have to play with is your x. And you can always, if you get confused, go to your table. Look at the numbers in your table to help you. Okay, one more. Half-life. How many of you have looked at a half-life in chemistry? Half-life. So, again, this is my initial. Now my B is a half. And here is my time. There are 4 grams after 10 days. Oh, here's my half-life. My half-life is every 12 days. So let's set up your equation. X over 12. So far we look like this. I didn't put my initial value in yet, and I didn't put my y in yet. So what is my initial value? I don't know. That's what we have to find out. So we're going to leave this as A. What are they giving us that we could use? 10 days, so where does that go? X. And how many grams will it be after 10 days? 4. So you have 2 choices. We can put this in y2. We could put this in y1. I will make this be my x. You can even solve this one algebraically, right? Because you only need to find A. This is important, guys. This exponent only belongs to this. So algebraically, all you have to do is divide both sides by this. Won't that find me A? Remember, that exponent does not belong to A. This is being multiplied. So if I divide both sides by that, 4 divided by this, and put it in your calculator like that, you have a nice fraction bar. So you don't even have to worry about extra parentheses. You should get your answer. And I don't know if I have an answer to this. Yeah, I guess. 127, good. And what are these? These are grams. If you put this in your calculator, let's see if we have time to quick put it in our calculator. You're going to massively change these windows. How come? Yeah, and they're very small numbers, right? I got small amounts. I was on 100,000 here. So let's put this in. I'm going to say A, which is my x, is 1/2. Just work with me on this, guys. We have like 2 minutes. 1/2, and I'm going to raise it to the 10. Whoops. I'm going to raise it to the 10 divided by 12.
Wait, why wouldn't that go from y1?
It doesn't matter which one it goes in. It just so happened I skipped over it when I cleared it. You can put it either way. It doesn't matter. It's still going to graph the same. Here's the problem. My days was before was my x. Now it's my amount. And if I'm 4 grams after 10 days, my half-life was 12. I didn't even half-life yet, did I? So I'm going to make this max be 10. Not even a max of 10. My y is my max of 4. So really, make that 10. And you should see them cross Again, if it bothers you that that's a straight line, just expand your X value, you'll see it slope a little bit better. Oops, wait a second, I'm not increasing, I'm I should be decreasing. It's the whole packet. Yeah, it looks long, but like there's like one on each page practically. I don't know why it's not decreasing. Increasing, why is it not decreasing?
Way too complicated.
I don't know why it's not decreasing. Alright, let me think about that, why it didn't decrease. I don't know why. Alright, so finish the packet for homework, guys.